In our mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contributions to our nation.
Hello, good morning, everyone. Good day. Good day, everyone. This is Professor Roger Flores of Central Mindanao University, Associate Professor of the Department of Electrical Engineering. Welcome you all to our subject EE41, Electrical Circuits 1. So I will be your professor to this subject, and I hope that I will be able to discuss to you everything that need to be learned or imparted to you. Okay, so today we are going to discuss chapter 1 of our subject. It is entitled Electrical Engineering, a brief overview. So here we're going to discuss a general overview of what is electrical engineering, subdisciplines of this engineering field, and then I will give you also an overview about the department of our department here in our university. Okay, so to begin with, we have here the background here is the landmark of the university, the commonly called Muswan Peak, the Mount Kalayu, and we have also our logo of our Department of Electrical Engineering. Okay, so here in our university, Central Mindanao University, Muswan, Bukidnon. Okay, so what is here? Let us try to talk about electrical engineering. Okay, so according to them, electrical engineering is an engineering discipline. No, it is an engineering discipline that deals with the study and application of the electricity, electronics, and electromagnetism. Okay, so it is understood that this is a field that will discuss electricity. No, it is a field that will discuss electricity, electronics, at the same time electromagnetism. Okay, so the practitioner of this field, the practitioners are called electrical engineers. Okay. It is also a broad field that encompasses many subfields. Okay, the electrical engineering is a very broad field, no, and it has several subfield that deals with power. Okay, that is number one. Then control systems. Then it will also encompasses the electronic subfields. Okay, so as we know that electronics is a field which will discuss small things, small components in the system, electrical system or in electricity. Okay, so it will also deals with telecommunications. Okay, telecommunications and communication system. Okay, so this time let us try to, I mentioned a while ago about telecommunications, about electronics, and this time let us discuss little thing, comparison between comparison between electronics communication engineering or electronics engineering or communication engineering with this electrical engineering. Okay, so just want to transfer to the other side. Okay, we have here the first comparison of the EE and the ECE, no? Okay, electrical engineering is considered to deal with the problems associated with the large-scale electrical systems. Okay, large-scale electrical systems such as power transmission and motor controls. Okay, we know that motor control is a dynamo or anything that that will produce, or a machine that will produce mechanical energy, no? That is a motor, electric motor. So electrical engineering deals with the control of this electric motor, whereas the electronics engineering deals with the study of small scale electronic systems. Okay, small scale electronic systems including computers and other integrated circuits. Later on, we will discuss what is this integrated circuits all about, or commonly called IC, ICs. Okay, another difference or comparison between these two fields is are usually concerned with using electricity to transmit energy. So when it comes to transmission, and we heard that this time our transmission system is managed or controlled by NGCP, or National Grid Corporation of the Philippines, here in the Philippines, no? So the transmission of this energy is the concern of an electrical engineer, while electronics engineers are concerned with using electricity to transmit information. Okay, information transmission is the concern of an electronics engineers. Okay, so how about the electrical engineering profession? So I will give you an idea what are the this profession all about. Okay, so first, the practice of electrical profession involves the art and science of developing, applying, and controlling the electrical, electronic, and related phenomena. Okay, so what we will be dealing here is, or the practice of an electrical engineer involves the art and science of developing, the applying, and controlling the electrical, electronics, and related phenomena of nature for the benefit of mankind. Of course, we'll be doing this for the people, for the human being. Okay, so it should be notably in the field of light, heat, power communication, and transportation. Okay, so the basic utility, the basic application of our field is, of course, providing good light, sufficient good light. And of course, sometimes we need to produce heat. Of course, in our households, we have different applications or appliances that produces heat, especially in the kitchen area. Of course, then power communication. Of course, this time communication system is very important. Okay, some of us seems to be, or seems not, cannot live without cell phone, without communication system, so on and so forth. And then of course transportation. This time, the government's trying to introduce to us this what we call as solar transportation or solar vehicle. No? So another thing, another application of this transportation applying electricity is the rail transit, no? LRT, MRT, in Manila. So that is, we are using electricity to let this vehicle move. No. Okay, so the graduates of this field or BSEE is qualified to become a professional electrical engineers or PEE. Okay, and also qualified to become a registered electrical engineers or we call this as REE or registered master electricians. Okay, so according to the Republic Act 7920 or 7920, the new electrical engineering law, uh, it emphasized the scope, the limitation, the scope of the practice of the registered master electricians and also the registered electrical engineers, and also uh, provides the emphasize uh, the practice of the professional electrical engineers. Once you will graduate BSEE or Bachelor of Science in Electrical Engineering, you will take the board exam. After passing the board exam, you will be given a certificate to practice registered electrical engineering, or you will be called registered electrical engineer. Then maybe after 5 years of practice, and then you will practice of our field, you will be given certification, and you are qualified to take upgrading, professional upgrading, which is called professional, if you will pass, by making documents, research, designs, and related activity, then defend it to the commission, the Professional Regulation Commission or the BEE, the Board of Electrical Engineering, and if you will pass, then you will be given a certificate and authority to practice professional electrical engineering. Okay, so these are the field that after graduation, after finishing the program, the BSA program, uh, qualified to become first a registered master electrician, registered electrical engineers, and then professional electrical engineers. Okay, what are the career opportunities? Okay, so we have here for the REE or PEE. You are now we can work as power plant engineer. Okay, we know what is power plant. No, we heard already that one. That the power plant is establishment, an institution that will produce, generate power or electrical energy. Okay, so we can work there as a registered electrical engineer and or professional electrical engineer. Then also we can work as a specialized sales engineer. Okay, so business entrepreneurship is encouraged this time. Of course, we can work as a businessman, but situate that what we will be selling is, of course, related or it is about a machine, for example, transformers, generators, motors, or it is any devices that is related to electrical engineering. Okay, and we can work as a designer, no? So, but only thing here is that only the professional electrical engineer can sign and sell our plan, electrical plan, or other installations that will be designed by us. Okay, and we can work also as an electrical equipment operator. Take note that we cannot energize, we cannot install if it is not supervised installation, or any registration is not supervised by an electrical engineer. Okay, in a machine, especially a bigger machine, uh, in the industry, in the company, then it should be managed and it should be controlled by an electrical engineer. both REA and of course the professional electrical engineer. Okay, so we can work as a researcher, of course, especially phenomenon that is present around us. We can do research, okay? Then after that, convert this idea and this phenomenon or findings into reality. That is our work. So being a researcher, we can work as an electrical engineer, we can work as a researcher. And of course, transmission line engineer. I mentioned a while ago that our transmission line is currently managed by NGCP or the National Transmission Corporation of the NAPOCOR, National Power Corporation. So we can work as a transmission line engineer, but take note, we will not be climbing the tower or in a post, no? And at the same time, we can work also as a faculty. Take note that this program, Bachelor of Science in Electrical Engineering, cannot be offered without a faculty, a professional or a currently licensed electrical engineer. So we can work in college, in the higher education, in the university as a faculty. Okay? So we can work also as consulting engineer or consultant, no? So basically, this is a good work, good job that it's not so very hard, but of course we need to be expert. Okay, so to become a consultant is not as easy as talking without researching, reading, and so on and so forth. Then we of course, it has a good opportunity also to gain. Okay, to gain, of course, money. Okay, so as a consultant to any establishments, any institutions, production, utilization, generation. Okay, we can work also as construction or installation engineers. Okay. Then inspection, appraisal, construction coordination engineer. Then maintenance engineer. Okay, so we can work all these things here. Of course, operation engineer, especially in the industry, in the generating plant. Okay, so they need always an operation engineers. Okay, being a registered master electrician or RMA, we have something also. We can work also as industrial electricians. Okay, so we know that basically what is the job of electrician? Basically, installations. Okay, installations of electrical devices, installation of electrical machines, or wiring installations. So that is our job as a registered master electrician. Or we can work as a service technicians. Okay. Then, of course, in the in during operations, we can work also as a maintenance technician of any plant and industry. Now, this time, let us talk about this sub-discipline. No? We will talk about these sub-disciplines. Okay, so we are here. No? So, first is power. This is a sub-discipline. We will discuss this thoroughly one by one. No? And then we have also electronics, microelectronics. Then signal processing. This is more on communications. No? So signal processing. And then instrumentation engineering. Okay, so this instrumentation engineering is doing measurements in charge of the measuring devices. No? We have this instrumentation engineering. And also control engineer. We can work as a control engineer also. This is another sub-discipline of our field. And the computers. Okay, so telecommunications also. So later on we will discuss this one by one. Okay, so let's begin with power. This power deals with the generation. Of course, talking about generation, it is either small, medium, or large, large what we call powerhouses or power generation systems. So here in Bukidnon, we have more or less one hydro and biomass generation and other form of energy generation. No? Talking about hydropower, we have the Napocor in Maramag, Bukidnon. Okay, so Pulangi 4 hydroelectric power plant is the only hydro power plant here in Bukidnon. Okay, so they generates up to more or less a maximum rating of 255 megawatt. Okay, so that is what the power engineering is dealing with. No? Another one is transmission. Okay, so the transmission of the energy generated to the load. Okay, so I mentioned already that basically here in the Philippines, transmission system is already majority is already privatized, no? So National Grid Corporation of the Philippines is one of the institutions in charge of the generations transmission. I mean, okay. So power engineering also deals with distribution of electricity. So here in Bukidnon, we have two distribution utilities or DU. One here at the northern part is the Busico, the Bukidnon Sikan Electric Cooperative. And then in the southern part, southern portion of Bukidnon, it is the area is supervised by the First Bukidnon Electric Cooperative Incorporated. Okay, so the power engineering also deals with the design of a range of related devices. Okay, so such as transformers, electric generators, electric motors, and others. No? So we have also power electronics. Okay, so power engineers may work in the design and maintenance of the power grid as well as the power systems that connect to it. Okay, so I think you heard already what is a power grid. Here in the Philippines, we have three grids, no? So we have the Luzon grid, we have the Visayas grid, and we have here the Mindanao grid. Now, presently, the Luzon and the Visayas grid are interconnected each other by using the submersible underground or submersible cables, no? Uh, Passing island to island. So we have that is the connection between the power connection between the Visayas and the Luzon. And they are now planning to connect also Mindanao. No, so anyway, maybe sooner or later, this whole Philippines, these three grids will be interconnected to each other. Okay, so we have here the control or control engineering. So this control engineering focuses on the modeling of a diverse range of dynamic systems and the design of controllers that will cause the system to behave in the desired manner. Okay, so it's very clear that what we'll be doing here is controlling devices, a machine, so that as what we desire to function, the machine to function, can be achieved. Okay, so how to do this? Then that is the job of a control engineer. Okay, this is to implement such controllers. Electrical engineers may use number one, electric circuits. Okay, so we have digital signal processors, and then microcontrollers. No? So and then so again, no, this so that we'll be able to implement this control subdisciplines or controlling or control engineering. Then an electrical engineer may use electrical circuits, digital signal processors, and then microcontrollers. Then, of course, this field plays an important role in industrial automation. So to have an easier implementation of or function of our industry, our company, then it is better to implement automation. Okay, so automation is also making our job much easier. Okay, so let's proceed to another subfields. No, it is the electronics subfield. Okay, so talking about electronics, it involves the design and testing of electronic circuits that use the properties of components. Okay, so such as resistors, such as capacitors, and other electronic components, inductors, and capacitors, resistors, inductors, and uh, the diodes, and what else? The transistors, no? So we have here the transistors to achieve a particular functionality. Okay, so that is the job of an electronics. Okay, to test, to design. Okay, resistors, capacitors, inductors, and diodes, no, and other semiconductor component or materials. Okay, so let's proceed to microelectronics. So this is much smaller than electronics component. No? So deals with this microelectronics engineering deals with the design of very small electronic components or component for use in integrated circuit. Okay, what is an integrated circuit? This is a chip. This is a very small chip that the has the characteristic of being a resistor, a conductor, a resistor, inductor, and a capacitor. Later in our field, in our subjects, in our chapters, we will discuss many things, or we will be more discussing about resistors. No, that is for chapter 3. The resistors, capacitors, and inductors. Okay, most common microelectronic components are the following. Of course, I mentioned semiconductor transistors, resistors, capacitors, inductors. No, so these are some of the uh, common microelectronics. Okay, so we have also the signal processing. Okay, so we have here the signal processing, and this signal processing deals with the analysis and manipulations of signals, of course. And signals can be either analog or digital, no? Digital. In which case the symbol or the signal varies continuously for according to the information that is for the analog, no, varies continuously. While talking about digital, signal varies according to the series of discrete values representing the information. And these discrete values are the smaller or the discrete values of the current transmitted, no, to be converted into information uh, message, no? An information or a message which is necessary to be transmitted. Okay, so talking about subfields, telecommunication subfields. Okay, so this is an engineering focuses on the transmission of information across a channel, such as coaxial cable, optical fiber, or free space. Okay, so this time optical fiber is very much common in the transmission, in cable, in video transmission, uh, internet, uh, telecommunications, and others. No, so fiber optic now is widely used, but of course there's still system that still using coaxial cable now as the means of transmission. So talking about channels here, so we have different channels. No, we have the wireless channel, cable channel, and other means of transmitting informations. Okay, so once the transmission characteristic of a system are determined, telecommunication engineers designed the transmitters and receivers needed for such systems. Now we know that in the communication system, it involves two important factors or part. Okay, we have the receiver, and at the same time we have the transmitter. So transmitter is anything that transmit the communication, the information, and it should be received by, of course, the receiver, and decode, convert this in, go back to the in the form of a message. No, okay. So next, instrumentation engineering. So this is all about, or it deals with the design of the device to measure physical quantities such as pressure, flow, and temperature. Okay, pressure, flow, and temperature, and other quantities, measuring quantities. Okay, so it should be done by an instrumentation engineering. So the design of such instrumentation requires a good understanding of physics. Okay, so that is why our field, you cannot enroll, you cannot proceed to higher electrical engineering subjects if you will not pass first the physics, because physics is the basic, the foundation of our field, no? That often extends beyond electromagnetic theory. So later on, we will discuss Faraday's law. We will discuss electromagnetic. Now it is called electromagnetic because, of course, production of this magnet is done by or supplied by electrical energy. Okay, it is different from natural magnet, which is from stone, or that is a permanent magnet. Some call this one as a permanent magnet. Electromagnetic, or the production of the magnet through electrical energy can be varied. Okay, it depends on the amount of electricity supplied. Okay, or the number of turned of these magnetic materials. No, copper wire wound in an iron. Okay, to produce this electromagnetism. Okay, so instrumentation engineering also is often viewed as the counterpart of control engineering. It is also viewed as part of control engineering. They are partners in a way. Okay, so let us talk about computer engineering. It deals with the design of, okay, the design of the computer and computer system itself. Okay, so when we say computer system, it includes already monitor, it includes the UPS, the power supply, the keyboard, the hard disk, and everything. Okay, so that is a computer system. So this is one of the responsibility of the computer engineers. But of course, it is a subfield of the electrical engineering, because we can this machine cannot work, cannot function without electricity. So this may involve the design of the new hardware. So what I was mentioned a while ago are about the hardwares of the computer or the software, no? So computer engineers also can develop softwares, okay, for the system to function. Okay, so other related fields not mentioned above, Okay, we have this Mechatronics. Okay, so what is this Mechatronics all about? So this is an engineering discipline which deals with the convergence of electrical and mechanical systems. It converges. There is a conversion or converging of the knowledge related to electrical engineering and at the same time mechanical engineering fields. And mostly they call this one as electromechanical systems. Okay, so according to them, these two fields are just cousin. No? So maybe because most of the time electrical engineering cannot work or maybe need to have a mechanical engineers or mechanical engineering technology or field or program to work to function. So this is vice versa. No, mechanical engineering also cannot work without power supply or electrical energy. So they will work or function hand in hand. Okay, so an example of this mechatronics is automated manufacturing systems. Okay, so automation is very important and in an industry. So this will be done by a mechanical technology, mechanical engineering technology, but of course it should be supplied by an electrical energy to work, to function. Heating also, ventilation, refrigerations, air conditioning. So these are some of the mechanical engineering job which will be of course cannot function as I've said without electrical engineering and other or various subsystems no, of aircraft and automobiles. Okay, another related disciplines is this what we call as biomedical engineering. Okay, so biomedical engineering. So there is what we call as relation with medicine and other health facilities, no, related job. So electrical engineering will come in here with this biomedical engineering field or subdisciplines, no, or related disciplines. Okay, so it is concerned with the design of medical equipment. Okay, the concern of the design of the medical equipment. Okay, this includes fixed equipment such as ventilators. Okay, so in the hospital, if a patient is experiencing hardship in breathing, then they will be using ventilators. But of course, the ventilator here can work or cannot work without electricity, of course. Then it will another machine in the hospital that is very useful also is this magnetic resonance imaging or this MRI. In fact, until now, as I hear that MRI or the magnetic resonance imaging is still the most precise and good machine that will be able to picture out what is in the body of within, no, the inside the human body, okay, by using this resonance imaging. Resonance means sound. Okay, if you will be able to experience this, um, it you can hear, no, in the laboratory room while this MRI is functioning, you can hear sound, no, something like tok tok sound or tick tock sound, no. Okay, then also scanners and electrocardiograph, no. So this call this one as ECG. It will of course it will this ECG will is a machine that will try to evaluate, okay, to check your heartbeats of your heart, no. Otherwise, if there is something wrong with our heart, then this graph that is produced by this machine, ECG, uh, will have a different illustrations, okay, or a wave. There is a distorted wave and others. No, doctors are very are familiar with that. Okay, so that is another machine, of course, that supplied by an electrical energy. Another mobile equipment machine or mobile equipment in the hospital, okay, such as cochlear implants, okay, not in the hospital, but we have here the cochlear implants, artificial pacemakers, and artificial hearts. Have you heard about cochlear implants? That is a very small device placed in our ears so that we'll be able to hear, especially if somebody have a problem in hearing, no? So it will be installed in our ears. Okay, and of course, artificial pacemakers, uh, or artificial pacemaker is a machine also uh, implanted here in our heart so that it will help our heart. It will give more energy to our heart to pump, normally operate or normally pump, no, blood, and so that this blood will equally or circulate our body. Okay, so these are some of these what we call as mobile equipment. Okay, so and artificial hearts also. No. Okay, so now let's proceed to the offering of the Bachelor of Science in Electrical Engineering in CMU. Okay, in Central Mindanao University. Okay, so Central Mindanao University offered this Bachelor of Science in Electrical Engineering. Okay, and it was the desire to supply part of the need. Okay, uh, the need of offering basic electrical engineering subjects. No, so that is why the college offers this subject, the desire to supply the need of the other program in our college, no, to offer basic electrical engineering. Okay, so we have the mechanical engineering, the civil engineering, the agricultural engineering. Okay, so they need to have basic electrical. So we have to function, no, and later on in the year 1984, this Bachelor of Science, a 5-year Bachelor of Science Engineering, was offered, okay, in the College of Engineering of this university. So it was June of 1984. Okay, it was this offering of the BSA program was legalized by the CMU Board of Regents uh, through the BOR Resolution number 98 series of 1983. So it was approved by the Board of Regents of the university to offer BSEE through the College of Engineering with this resolution number 98 series of 1983. Okay, so BSEE was formally created uh, in 1975. Okay, so it was formally created in 1975 to what do you call this one? To, as I mentioned a while ago, to offer services, offer basic electrical engineering to the other program in the university or in other college or in other in the college, no? In other department. So we call this one a service department. Now, in the early 1980s, the government engaged in a nationwide program of hydroelectric power development. Okay, so 1980s, no? So the government now, during that time, it was during Marcos' time, that tried to uh, implement projects in electrification. And because of that, it seems that crisis was uh, felt during that time. So that is why the government tried to develop or implement is what we call as hydroelectric development. Okay, there is resulted a tremendous need for the service of electrical engineers because of that, no, project of the government. So the department produced a number of anyway, so that it was the reason why we offered this electrical engineering. So the Department of Electrical Engineering has been already producing several graduates already, hundreds of graduates already since 1989. Okay, so the program was officially offered 1984, 1984, 85, and then 88, 89. So it was the first batch, no? 1989. Okay, so majority of whom are licensed already by Professional Regulation Commission. So I think almost all, maybe there were few, but of course it is just few. Majority are already licensed, both registered EE or uh, professional EE. And it was 2005 that our department produced uh, first pleaser, oh no, the produced a pleaser in the board examination, and he landed in as the fifth pleaser all throughout the Philippines, no, and he was Engineer Leo Marconi Carillo. Okay, so he was the first graduate of the department who became the fifth placer during the board examination. It was 2005 board exam. Okay, so in that year also, the Department of Electrical Engineering or the university become number three top performing school nationwide as declared by the Professional Regulation Commission. Okay, and later on, 2008. After that, we have already several graduates, and we have already several placers also. Okay, with different place. We have number 10, aside from number 5, number 10, number 8. Lately, we have number 8, and so on. So, modesty aside, that is the record of our graduate here in the university. It was May 2008 that one of our graduates became or upgraded to professional electrical engineer. And it was Engineer Pastor Di Abrigana. Okay? So he is now presently working in the National Power Corporation Pulangi Hydroelectric Power Plant in Maramag. One of the uh, possessing a highest position in that institution. Okay, so a managerial position, in other words. So actually, Engineer Pastor Abrigana was or is one of our first batch, no, of the department. Okay. So recently, also as I mentioned, last May 2019, the department received a certificate of distinction for being top 7 again, top 7 performing school nationwide for the registered electrical engineering board exam, and it was conducted last April 2019. Okay, so we were able to gain our position in the list of schools, colleges, universities in the Philippines who offered Bachelor of Science in Electrical Engineering, and we topped during that board exam, being we placed top 7. And one of our graduates during that time was landed as number 8, or he became the 8th placer of the board examination. He was or he is Engineer Janjo Carcillar. Okay, so the it is the most recent board exam result, and Janjo Carcillar landed as number 8 of that board examination, and the university landed as top 7 of high performing school nationwide. Okay, ever since, our university passing rate is always above the national passing, and there was a time that we have 100% passing, but it there was no chance, or there was no time that that our university got only less than that of the national passing. Okay. Okay, so just to share with you the objectives of the program. Okay, so we have here the first objective of the program is to consistently produce technically competent electrical engineers needed by the agricultural, industrial, and manufacturing sectors. Okay, so that is what we aim to produce, no? Then we aim also to produce, to continuously provide dynamic, relevant, and comprehensive instructions for both degree and non-degree programs in electrical engineering. Until this time, we are still planning to offer non-degree programs. Okay, so anyway, we will the department is still dreaming for offering these non-degree programs. Okay, to actively conduct research and extension activities to advance and disseminate electrical engineering technologies in Mindanao, particularly in areas of instrumentation, areas of control, power generations, communications, and information systems. Okay, so anyway, the department have started already this one, and we have already our research, we have already our extensions activities. So I forgot to list here some of these activities, but of course it is true. Okay, so we have some listed here. We listed here some of the EE websites, but of course this time you can use your internet to open some of these websites related to electrical engineering. So we have here some of the we listed here some of these websites that is related to electrical engineering. Okay, so we have this one here, and that is the, I think we discussed everything here. This is related to electrical engineering, and I hope that I give you an overview, a complete overview. If not, then little things about electrical engineering that might encourage you to proceed, no, to continue, to finish our field, take the board exams, and practice being an electrical engineer. Thank you very much. Thank you for listening, and until next chapters, next discussion, next video. So I hope that you like and subscribe my YouTube, and I hope that continue studying, reading related to our field, and hopefully few years from now, 4 to 5 years, 6 years, we will meet again and be one of the most high technology and engineer, no, of this field. Okay, thank you very much, and God bless us all.
We are one in mission and vision in sealing